Welcome everyone. In previous videos, we learned how to compute the derivative of a function. We also learned how the equation of a line can be written. Now in this video, we're going to put together those two informations to find the equation of the tangent line of a function. Okay, so we're given with a function in here. So function is y equals x sine x. And now we're going to find the equation of the tangent line of this function at point 5 pi on 2. No, it's minus 5 pi on 2, 5 pi on 2. So we're going to find the tangent equation of the tangent line of this function at this point. Okay, so why don't you pause the video here and then try it yourself, and we'll come back and do it together. First of all, we need the equation of a line. So the equation of a line has two different forms. One is slope, a point slope form, which is y minus y0 equals m x minus x0, or there's a slope intercept form which you can use, y equals mx plus c. So if you're looking carefully in this one, so we're given with y0 and x0. That's one point. That's one point of this tangent line, which is this point. And what we need is m. So even if you use this equation, so all we need is m, and then you can work out c. So it's fine to use any of this equation, but for any equation to work, we need to get m, the slope of the line. To find the slope m, we can use a knowledge on the derivative of a function. So the derivative of this function gives the equation of the slope of the tangent. Okay, so the derivative gives us the slope of tangent, or the function. So because that's a function, the derivative is a function that describes the gradient of the tangent at any point of the function. Okay, so to find m, we first find the derivative of this function. So it's a y dash equals okay, so what should we do now? So we find the derivative, and then that will give the slope of the tangent, and then the slope of the tangent can then be plugged into this equation to get the equation of the line. Simple, isn't it? So first we find the slope of the derivative of first we find the derivative of the function, so y dash. So to find the derivative of this function, this particular function is of the form u times v. That's a product of two functions, so we need to use the product rule. So we already learned about product rule. If y equals uv, the product rule is saying y dash equals uv dash plus vu dash. So we've done many examples, so I'm just going to write everything in the one go. So that's u is x, and v dash is the derivative of sine x, which is cos x. The derivative of sine x is cos x, plus v is sine x, times u dash, the derivative of x, which is 1. So that is x cos x plus sine x. So this is a function. So this function, so the y dash, the derivative, is a function that describes the gradient of the tangent at any point on the graph. Okay, so this gives the equation of the gradient at any point. Okay, but what we need is what is the gradient exactly at that point. So what you have to do is we need to find y dash, the derivative y prime, at minus 5 pi on 2, 5 pi on 2. That's the exact point we are after the slope of. So it's a m equals that value. So that's when you substitute this x value in here. So it's a minus 5 pi on 2 cos minus 5 pi on 2 plus sine minus 5 pi on 2. So now we can use the properties of the sine and cosine functions here to simplify the whole thing. So we have cos, or you can use the calculator if you have access to the calculator. So cos minus theta equals cos theta, and sine minus theta equals minus sine theta. So this equation then becomes m equals minus 5 pi on 2 cos 5 pi on 2 plus minus sine pi on 2, because sine minus theta is minus sine theta, so that is minus sine 5 pi on 2. So this then can be written as minus 5 pi on 2 cos 5 pi on 2 can be written as 2 pi plus pi on 2, right? And then minus sine 2 pi plus pi on 2. Okay, so 2 pi cos 2 pi plus theta equals cos theta. That's another identity we can use. And also sine 2 pi plus theta equals sine theta. So these are the two identities that's useful in here. So this simply becomes minus 5 pi on 2 cos pi on 2 minus sine 2 pi plus pi on 2 is sine pi on 2, and cos pi on 2 is 0, so this term cancels out, and this is minus sine pi on 2. Sine pi on 2 is 1, so this is nothing but minus 1. So the slope of the tangent is minus 1. So now it's all about substituting this value of m into this equation and getting the equation of the tangent at this particular point. So now we've got m equals minus 1, and we can substitute this value of m and this point into this equation to get the equation of the tangent line. So that becomes y minus y0. y0 is 5 pi on 2, 5 pi on 2 equals m, which is minus 1, times x minus x0, x minus minus 5 pi on 2, that becomes 5 pi on 2. Okay, so like we can do a little bit of rearranging in here, and we can get to the slope intercept form by just rearranging, because mostly people prefer to write that in this form. There's nothing wrong in completing the equation. There's nothing wrong in stopping in here, but sometimes it's most preferred to have this sort of expression. So we can do that in here. Sets of y minus 5 pi on 2 equals minus x minus 5 pi on 2 when we multiply this minus 1 with both terms inside the bracket. And then if I'm adding 5 pi on 2 on both sides of the equation, this 5 pi on 2 cancels out, and then the equation I get is y equals minus x. Okay, so this is the equation of the tangent line at this particular point for this function y equals x sine x. So in summary, this question asked to find the equation of the tangent line for this function at this particular point. So we knew that the derivative will give you the slope of the tangent. Okay, so we found the derivative and we found the slope. Then we substituted that into this equation or any of the equation of the line. Okay, so hope this makes sense to you. We'll stop it here, but do as many examples as you can to master this topic.